Hello students, today we'll discuss a science passage. This is passage 5 of the reading section of the March 2021 US SAT paper. So let's begin. So this is a paired science passage. Passage 1 is adapted from Free Floating Planets May Be More Common Than Stars, published in 2011 by National Aeronautics and Space Administration. And passage 2 is adapted from Ashley Yeager, Fewer big rogue planets roam the galaxy, recount shows. Right. Okay. Let's start reading the first one. A survey scanned towards the center of the Milky Way galaxy during 2006 and 2007, revealing evidence for up to 10 free-floating planets, roughly the mass of Jupiter. The isolated orbs, also known as orphan planets, are difficult to spot and had gone undetected until now. The planets are located at an average approximate distance of 10,000 to 20,000 light years from Earth. This could be just the tip of the iceberg. The team estimates there are about twice as many free-floating Jupiter-mass planets as stars. In addition, these worlds are thought to be at least as common as planets that orbit stars. This adds up to hundreds of billions of lone planets in our Milky Way galaxy alone. Okay, so the concept of a free-floating planet according to the passage, is a planet that doesn't have a sun to revolve around, right? And Jupiter-sized free-floating planets have been discovered about 10 to 20,000 light years from Earth. And the possibility of many more such lone planets existing is discussed. Our survey is like a population census, said David Bennett, a co-author of the 2011 study. We sampled a portion of the galaxy and based on these data can estimate overall numbers in the galaxy. The survey is not sensitive to planets smaller than, that is with lower mass than Jupiter and Saturn, but theories suggest lower mass planets like Earth should be ejected from their stars more often. As a result, they are thought to be more common than free-floating Jupiters. Okay, so these two paragraphs talk about how the authors arrived at a number for lone planets based on uh, a technique which is similar to sampling, that they sampled a portion of the galaxy and based on that they figured out the number in the galaxy. And the next paragraph from line 20 to 25 discusses the possibility of smaller mass lone planets being higher in number because they are it's easier for them to kind of get out of the gravitational pull of their stars, right? But that is something that this survey was not able to capture because it was not sensitive to planets smaller than the size of Jupiter and Saturn. Previous observations spotted a handful of free-floating planet-like objects within star-forming clusters with masses 3 times that of Jupiter, but scientists suspect the gaseous bodies form more like stars than planets. These small dim orbs, called brown dwarfs, grow from collapsing balls of gas and dust, but lack the mass to ignite their nuclear fuel and shine with starlight. It is thought the smallest brown dwarfs are approximately the size of large planets. Okay, so this talks about other free-floating objects which are not planets, but which are actually stars that were not big enough to emit light, right? Because um, because you need to have a certain mass to be able to ignite the process, right, of producing light, and which is fusion, right? Yeah, fusion, because when two hydrogen atoms combine and create helium, that's how stars work and emit light. So that process doesn't happen with these bodies called brown dwarfs. So that's like this other category of lone objects that are not planets. On the other hand, it is likely that some planets are ejected from their early turbulent solar systems due to close gravitational encounters with other planets or stars. Without a star to circle, these planets would move through the galaxy as our sun and other stars do, in stable orbits around the galaxy's center. The discovery of 10 free-floating Jupiter supports the ejection scenario, though it's possible both mechanisms are at play. Okay, so there's another scenario which could explain this. The other scenario is that there were some planets which were ejected from their solar systems and now have come to kind of revolve around the center of the galaxy itself, right? So the center of the galaxy can be thought of as this really massive entity, I would say, that also kind of gets other stars, the big stars like the sun and other stars to revolve around itself. So these free-floating planets behave as if they were revolving around the center of the galaxy. If free-floating planets formed like stars, then we would have expected to see only 1 or 2 of them in our survey instead of 10, Bennett said. Our results suggest that planetary systems often become unstable, with planets being kicked out from their places of birth. Okay, so let's go and look at the questions. Do the results of the survey described in passage 1 support the conclusion that there are twice as many Jupiter mass free-floating planets as Earth mass ones? Twice as many. Okay, so I think with a very specific question like this, it's always a good idea to look at the line numbers. So let's just go to 1 to 4, 9 to 11, 20 to 23, and 26 to 30. Okay, so 1 to 4 says, a survey scanned towards the center of the Milky Way galaxy, revealing evidence of up to 10 free-floating planets. So this just talks about the Jupiter-sized planets. This could be just the tip of the iceberg. The team's estimates that there are about twice as many free-floating Jupiter mass planets as stars. So twice as many Jupiter mass planets as stars. I don't think it talks about Earth. It's not making a comparison between Jupiter mass free-floating planets and Earth mass, right? Okay, so let's just read the rest of it. 20 to 23, the survey is not sensitive to planets smaller than Jupiter and Saturn, right? So, so this should be the reason that it doesn't talk about Earth, but Jupiter and Saturn, but theories suggest lower mass planets should be. Okay, so that's, and 26. Yeah, that doesn't talk. Okay, so I think the answer for 44 has to be C, because that talks about how the survey doesn't consider Earth mass planets. And the answer for 43 has to be no, because it does not include direct information. Should it be D or C? 1 second. The survey is not sensitive to planets smaller, but theories suggest lower mass planets like Earth should be ejected from their stars more often. So that's a theory. It does not. Yeah, so I'd go with D, because that's not something the survey talks about. The fact that there are more Earth mass free-floating planets, that's not something the survey talks about. The survey simply does not include direct information. Okay, what about, okay, 45 is passage 2, so let's just go to passage 2. In a new study, Rezmek Mroz of the Astronomical Observatory of the University of Warsaw and colleagues estimated the number of large rogue planets in our galaxy using a technique called microlensing. When an object with the mass of a planet passes in front of a distant background star, the gravity of the planet acts as a gravitational magnifying glass. It distorts and focuses the light, giving up the planet's existence. Okay, so this kind of describes the process by which Mroz and his colleagues discovered the rogue planets, the process called microlensing. Okay, Mroz and colleagues looked at 22,617 microlensing events recorded between 2010 and 2015 and determined which were caused by a rogue planet. For every typical star called main sequence stars, there are 0.25 free-floating Jupiter mass planets, analysis suggests. The new result sharply contrasts an estimate published in 2011, okay, which suggested that rogue Jupiters are almost twice as common as main sequence stars. Okay, so this is interesting because now I am seeing data that contrasts with what the first passage talked about, right? Because the first passage was the 2011 passage by NASA, and it did say that uh, the team estimates that there are about twice as many free floating as stars, right? But this says that actually no, there are about 0.25. So that means that rather than twice, it's 1/4 the number of typical stars. About 90% of stars in the universe are main sequence stars. So if that estimate were accurate, there should be a lot of free floating Jupiters. That result changed our conceptual. If that estimate, okay, the estimate of, yeah, there should be, okay. That result again refers to the 2011 result, changed our conceptual framework of the universe just a little bit, says astronomer Michael Liu of the University of Hawaii. It challenged long-held ideas about how planets go rogue because the known methods wouldn't generate enough planets to account for all the wanderers. Right. Okay. So this is kind of looking at the earlier study, the NASA 2011 study that said that for every main star, there were about twice the number of Jupiter-sized rogue stars, rogue planets that had gone lone, that had kind of escaped the gravitational pull of the star. And that is something that was not completely explained by the theories at the moment. That is what Michael Liu of the University of Hawaii is saying. The 2011 result was based on a relatively small sample of microlensing events, only 474. Since then, infrared telescope images haven't detected as many free-floating planets as expected. Over the years, serious doubts were cast over the claims of a large population of Jupiter-Mars free floaters. Okay, so the other study was published in 2017. So over that 6-year period, that sampling method that was used by the NASA study was shown to be not accurate because um, the there were the other instances of lone planets were not recorded. David Bennett, co-author of the 2011 study, agrees that the new census failed to find evidence for a large population of Jupiter-Mars rogue planets. He notes, however, that the new data do reveal 4 times as many Jupiter-Mars failed stars called brown dwarfs than predicted in the original census. So some of the rogues that were originally classified as planets may in fact be failed stars. Okay, interesting. So there was this other thing that was going on, right? In the first study, the NASA study, that that there was a like whatever lone and rogue bodies were floating around, there was some debate about whether they were planets or whether they were failed stars known as brown dwarfs, right? And what David Bennett, who was a co-author of the NASA study, is saying that it is possible that that what we thought of as planets were brown dwarfs because this new study, the 2017 study, does reveal 4 times as many Jupiter-Mars failed stars called brown dwarfs than was predicted in the original census. Liu says the latest census is much more in line with theories of how planets form. Most rogues should be Earth mass or a little heavier. Those lighter planets get tossed out of their planetary systems much easier than behemoths like Jupiter. Right. And then the final paragraph kind of says that the new census agrees with what is commonly believed and what is commonly understood about planet formation, that if a star has to go rogue, it should probably be the mass of Earth, right? It should not be the mass of a massive object, a behemoth like Jupiter, because it is the smaller planets like Earth that get tossed out of a solar system because the gravitational pull of the sun on such planets is smaller compared to on bigger planets. Okay, so let's do 45. According to passage 2, Mroz and colleagues analyzed microlensing events to confirm the results of Bennett and his colleagues' survey, discover the minimum required mass for a planet to be detected, Compare the relative sizes. Okay, so I'm just going to read that part once again. Number of, using it when an object with the mass and determine they were caused. Right, so they did this. Okay, discover the minimum required mass for a planet to be detected. Compare, determine. Okay. Which were caused by a rogue planet. Okay. Right. I don't think A is the correct answer. They were not trying to confirm that. Is it? No, I don't think they were trying to discover the minimum required mass. No. Yeah, it's D, right? They were trying to do their own independent work on how many big free-floating planets exist in the Milky Way galaxy. They were trying to, yeah, so they were trying to find that, and they came up with an estimate. Yeah, they came up with an estimate. So they were just trying to kind of do their own study. So I'll go with D, right? As used in line 78, account for most nearly means. 78, okay. It challenged long-held ideas about how planets go rogue because the known methods wouldn't generate enough planets to account for all the wanderers. So to explain, yeah, this should be explained, not explained. So it would not explain all the wanderers, right? Because you're trying to kind of talk about known methods, which would not explain all the wanderers. So 46 is A. Okay, the sixth paragraph of passage 2 serves as both 85 to 92. David Bennett, he agrees, but he also notes, okay, a corroboration of recent results and a suggestion of a potential flaw in the method. I don't think he discusses a flaw in the method. A criticism of the method and a recognition of the method's technical sophistication. An acknowledgement of recent findings and an explanation for how they might reflect. A revision of a previous claim and a rebuttal of a criticism of a previous research study. Okay. So is he agrees that the new census failed to find evidence? Okay, so he agrees, right? A revision of a previous claim. He notes, however, that the new data do reveal. Okay, so is it a rebuttal of a criticism? As many Jupiter mass failed, just in one sec. Yeah, so I was saying that, so I think what he's doing is that he's acknowledging the results, but he's also kind of giving a new interpretation of what they could mean. Yeah, I don't, so I'm kind of looking between C and D. Is it a rebuttal? Is he kind of saying that? I think it's C, right? I don't think it's a rebuttal of a criticism of a previous research study. I don't think the criticism was to do with, yeah, I don't think, right, I don't think it was about, yeah, he's not revising the claim and he's also not rebutting, right, a criticism. He's kind of acknowledging them and he's saying that, okay, I think the the total numbers might be close to what we predicted, but some of the planets we thought about could be failed stars, right? Yeah, so I'm going with C. I think I like C better. Yeah. Okay, as used in line 59, giving up most nearly means. So let's look at 59. It distorts and focuses the light, giving up the planet's existence. Okay, so that means it reveals the planet's existence, right? That's what microlensing does. So to reveal, yeah, that's an option. So D. Which choice best describes the relationship between the two passages? The results of a study outlined in passage 2 challenge the results of a study outline. That sounds like a good answer. The scientists discussed in passage 2 extended the research presented into a new field of study. No, that's not correct. Data shown in passage 2 support the hypothesis. That's not correct. The researchers of passage 2 identified variables. No, that's not correct. So A is very clearly the right answer. The results challenge the results of study 2 challenge the results of study 1. On which point about free floating Jupiter mass planets do the passages most clearly disagree? So that would be the number, right? The number of free floating, because the first one says twice the number of known stars, and the second one says 1/4 the number of known stars. Whether there are free floating Jupiter mass planets, no. Their existence is there. So whether they exist or not is not in question. How many there are, yeah, that's the point of difference. Whether they can distort and focus light, that's not a point of disagreement. Both passages, both studies use microlensing. How similar? No, that's not true either. So B is the point of difference. Okay. Which choice provides the best evidence? So I'm just going to write down the line numbers, but I think it's the part where he talks about the 0.25 bit. 51 to 55, 60 to 62, 66 to 69, and 95 to 97. Okay. So 51 to 55 is saying in a new study, yeah, that's just microlensing, so that's not which 60 yeah, so it's 66 to 69, right? That's where we are saying that the contrast is with that study. Yeah, so it is C. Okay. Right, and then 52. Which scientific idea is suggested in both passages? Lower mass planets are more likely to be ejected from their stars than Jupiter mass planets are. Yes, that is suggested. In fact, that's also suggested in the first one, right? Yeah, it is, because he says that they should be more common than Jupiter mass. So it's very clearly A. Brown dwarfs do not possess enough mass to produce their own source of light. That's only in the first one, right? Free floating Jupiter mass planets are nearly as common as planets that orbit stars. Free floating Jupiter, I don't think that's brought up. Is that brought up? No, I don't think there's a comparison of free floating and non-free floating. So C, I don't think is brought up. Rogue planets are easily confused with Jupiter mass failed stars by astronomers. Yeah, that is something that is brought up in the first passage. But yeah, the one which is suggested in both is clearly A, that there is a likelihood of Earth's size planets to be ejected than Jupiter's size. Okay, I think we are done with everything, but before I grade this, I'm kind of still looking at 47. I think I'll go with C, yeah, because it just sounds better. It just sounds a little more neutral. And you know that neutral answers are better than extreme sounding answers. So, but let's see. Yeah, let's grade it. Okay. So this is from this went from 43. So DC, okay, DACDA, DACDA, BCA. Okay, great. So we got all right. Okay, so this was the fifth and the final passage in the reading series that we did for the March 2021 US SAT paper. So I'm going to put all five in a playlist and you can kind of go through all of them. I would strongly recommend that you do these passages live with me when you watch the video, because that would really help you kind of look at your own thinking and analyze the process that you follow, right? Okay, that's it for today for now. Hope you found the video useful. Please subscribe to the channel if you did. This would help us grow and find more subscribers and find more users whom we can help. Take care. See you. Bye bye.